Okay, so page four is a real hybrid. The first three problems are work and power. The last two are just conservation of energy. So for A, B, and C type stuff, right? I'm going to do work, force, since, right? And so the first question is the same first question. Guys, can we keep it down to a lower roar? Class, 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 hello, hello. Can we keep it down to a lower roar? Okay, so A, B, and C, and I can't remember what it is. I think I asked for intermediate questions in there, so we can figure out what it is. I've condensed them down to just two questions, right? So what force must the tractor exert to slide the sled at a constant speed? Well, that's just the force of friction, right? And so the force is going to be mu times m times g. So 0.72 times 8,700 times 9.8. So this is 61,387. Yeah. Then it says, how far can it drag the sled in 3 minutes, right? So the time is going to be 3 minutes, right? So that's 3 times 60, 180 seconds, yes. So don't forget to turn it into seconds. And the power is 47 horsepower, right? So that's 47. This is number 4, right? 47 times 745. And I do the exact same thing on the test. I tell you the horsepower. You don't need to put it in your little cheat sheet, but it wouldn't hurt. Okay? So 47 times 745.7. 35,047.9 watts. Right? And we're going to drag the thing 103 meters. Oh, wait, no. This is what we want to find, yes? Is that right? Okay. So I think the thing to do is to use the relationship between this, this, and this to find this, and then find the distance. Right? Yeah, the power triangle, right? So work is going to be power times time, right? Okay, so work is going to be this guy times this guy. That's joules per second times 180 seconds. Heather. Ha! Wisner. Yeah. There we go. Well, you told me like 2 days ago, so it would be really sad if I didn't remember that. So this is just a lot of work. Yeah? Are we good so far? And then what's the relationship between work, force, and distance? Yeah, there we go, right? So it's work, force, distance. Distance is work divided by force, right? So it's that 6,308,622 joules. Now, if you've been rounding, you're going to get something slightly different. But
how did you get that?
I got it by saying that it was the watts times the seconds. Hey. Right? Yeah? Is that good? So now this is a very exciting moment. People are on the edge of their seat. I'm going to divide that very large number, right? Because it's work divided by force. So it's going to be 6 million joules divided by the force, which is 61,387. This will give me distance, so divided by A. Then I get 102. Yeah. So I do think that on the test, I think I ask you for the work. I think that's the other question, something like that, or one of these intermediate answers, and then the distance, right? I think, but I don't remember what the order is. And then the last part, and I'll tell you something that's not on the mock test. The pop fly, this is a pop fly question, right? And this is question C from that thing, right? Is that the ball is hit here at some elevation, right? Kapow. And it is seen at an elevation of 9 meters, right? Traveling at 60 meters per second. And it's 9 meters above this. Yeah? Okay. I'll tell you this. There's two questions we can ask now. This question is, what speed did it leave the bat? Yes? What's the other question we could ask? What's the greatest height that it reaches? I believe that's the other question. I'm not sure, but I think that's what it is, right? Right. I'm saying there's two different questions you could ask, right? And I think the other question is, how high does it go? Yeah? Yeah, we could do that as like a little bonus here if you want, right? So, what kind of energy do we have here? And potential, because it's 9 meters above the bat, right? So we can say mgh plus 1/2 mv squared equals, and then here what do we have? We have just kinetic, right? And I've written it backwards. This is really before and this is really after. Yeah? But that's okay. Are we okay with that? Or is that too confusing? That's kind of confusing, isn't it? I better write it the other way. Right, so down here it's got only 1/2 mv squared, right? Up here it's got kinetic and potential. Now, do you guys like solving these, canceling the masses? Do you prefer that, or do you prefer just put the mass in there? Put it in there. Keep the mass, all right. So let's go 1/2 0.145 times, we know it's going of 16, right? Whoops, no, we don't know how fast it's going. So it's just v squared, right? And then it's 0.145 times 9.8 times 9 plus 1/2 0.145 times 16 squared. So now I'm going to take the calculator and do this whole side here. So 0.145 times 9.8 times 9 plus 0.5 times 0.145 times 16 squared. And this whole side here is 31.349. Right? And now I'm going to multiply this by 2, divide by this. So times 2 divided by 0.145. And then I have to square root it, so I'm raising it to the 0.5 power.